In this presentation, we're going to go over the fundamental concepts around hypothesis testing. The basic idea behind hypothesis testing is that you have a population and what you want to do is you want to be able to infer about, let's say, some sort of parameter about this population. So in order to do that, what we do is we randomly select samples or members from this population, and we essentially take measurements of these samples. So let's call them x1, x2, x3, and x4. And this, essentially, the whole group becomes our sample. And ideally is that we want to make decisions about a population, so more specifically make decisions based on parameters associated with that population using the data from the sample, so using that measured data that we collected for each of these members of our sample. So for example, let's say we want to figure out the mean of some attribute or parameter of the population, and which we represent as mu. Again, that's mean. So for an example, we could determine if solar cells have a mean power output that is greater than a certain threshold. So basically from that, if we have solar cells that are producing an output of, let's say, 0.5 watts on average, then we can make an inference about the population. So now I want to sort of define specifically what a hypothesis test is and what these hypotheses are. So a hypothesis test is essentially just a test between two different hypotheses, and the hypothesis is essentially just a statement about a parameter for a population. So for our PV example, the hypothesis could be something as simple as the average power output of a solar cell is 0.5 watts. So the first one, which we call H naught, is equal to mu, which is the mean of the sample. The mean of the population. And that's equal to some value that we set. And the alternative hypothesis, which we call H1, essentially says similarly, mu, again, that's the mean of our population, is not equal to mu naught. So we actually call this one the null hypothesis. And again, this one is the alternative hypothesis. And ideally, our hypothesis is to typically be to look at the data and see if it provides enough evidence to reject the null as being false. So that's typically what we do in statistical testing. So there are a couple other things I want to talk about, and that it's sort of more having to do with our alternative hypothesis. For our alternative hypothesis, again, which states the mean of population is not equal to mu naught, we call this a two-sided test. And essentially, it's because we're trying to determine whether or not the mean is equal or not equal to a particular value. So essentially, the alternative hypothesis is that the mean is actually smaller than or larger than mu naught. So it's either smaller or larger, and so we call it the two-sided test. So again, the two-sided test looks like this. But there are situations where we want to have just a one-sided test. And so our one-sided test essentially is that we pick either up or lower or above the mean. And so our first one is where the mean is less than mu naught, and we call that our lower one-sided. And the second option is when the mean is greater than mu naught, and this is an upper one-sided test. So depending on what I want to know about my data will determine what type of test to use. So for example, if I want to know if the power output is equal to 0.5 watts, I will use a two-sided test because I'm specifically looking for that value. However, if I'm trying to determine if the power output is less than 0.5 watts, then it's a one-sided lower, versus if it's greater than 0.5 watts, then I'll use a one-sided upper. And essentially, we choose the type of test we are going to use based on the type of question we are asking. And the determination of rejecting the null, again, which is this hypothesis, will ultimately be determined by the type of test. So we can use a one-sided or a two-sided test comparing that to this in order for us to ultimately accept or reject the null. So I hope you have a better understanding of what hypothesis testing is, and what two-sided versus one-sided tests, and specifically what the null hypothesis is, and how we compare them based off of our sample that we pull from our population in order to make decisions about our population. Thank you.